Good morning, everybody. Thank you for your patience as you've been waiting for 11.4. I didn't realize that it wasn't online. So happy early Thanksgiving. And it is the day before if you've been working hard through chapter 11. And I've got 5 examples. 11.4 is really pretty quick. And so I've just got 5 examples that we can go through here, and that should help you through the homework. My math lab was being a little glitchy this morning, so I wasn't able to check every single homework problem, but I was able to see most of them. And so I think this will be pretty much parallel to what you'll see on the homework, and then, of course, what you'll see on the test. So the objective for 11.4 is just to manipulate formulas, and so you can solve for a different variable. And so in this first one, it's asking us to solve for L. So if you use different colors or things like that when you're trying your practice, you can always kind of identify that by making a circle around it or something along those lines. So you kind of get a sense of what you need to do to get L isolated. So the first thing I notice is that this 2W needs to get to the other side of the equal sign. So I'm going to subtract over that 2W. And P and 2W are not like terms, so I'm going to keep those separated. Order doesn't really matter. And so right away when I jump that 2W over, I'm almost done because the only thing left, you're kind of unpacking it, if you will, doing all of the things that are the opposites or inverse. So right here, we're going to divide by 2. We're going to divide by 2. And so this would be a perfectly acceptable answer for me. Of course, my math lab has proven to be slightly trickier sometimes, every once in a while, in how they want their answer format. So if you are required to split it, it would be P over 2 minus, and then if you have 2W over 2, then those 2's would cancel out. And so your final answer would look like this. To me, this is a perfectly acceptable form of the answer as well. All right, next one. This looks much harder than it actually is because we've got this fraction. This is actually the formula for the area of a trapezoid, if any of you remember your geometry from high school. And so I see this 1/2 here, and the first thing I want to do, if I want to solve it, I want to solve for h. Sorry about that. So if I want to get h by itself, basically all this stuff in front of it has to get over to the other side of the equal sign. So I think about what the opposite is of dividing by 2, and I can get rid of that fraction by multiplying both sides of my equation by 2, because that's just going to cancel that out and bring it there. So rewrite if you'd like. We have 2a now equaling parentheses b1 plus b2 times h. Our gut is to distribute, but then we have h's in 2 different places, so this is actually a better position to be in because h is being multiplied by that whole parenthesis. So I'm actually just going to divide by everybody there. Divide by b1 plus b2. Divide by b1 plus b2. And so my final answer, that's going to cancel that out there. I always like to write it with the h by itself on the left. So we've got 2a over, and you don't really need parentheses here, just have it. So if you want to take them off, that is a great form of the answer. Let's try another one. At any point, you can obviously pause and try it on your own. So this one is Pythagorean theorem, a squared plus b squared equals c squared. I chose solving for b, so we're going to get the b by itself. We're also going to have to deal with this squared. situation, and I know that there are both some radicals and some squares in the MyMathLab homework that I was able to see. So the first thing we need to do is jump this a squared over that equal sign. So let's just subtract. So we've got b squared equals, and then here, is there a right way to write this? I don't know. I always like to write it so that we're not starting with a negative if possible. So I would do this. A different text might have that in reverse order. There's no really right or wrong. And now we need to get rid of this squared. So the undoing of a square, the inverse of a square, is to square root. So I'm going to square root both sides, and that is going to break that free and cancel that out. So my final answer is b equals the square root of c squared minus a squared. And there are some situations where there might be a plus or minus in front of this. We have to take the positive radical in this case because I know that this formula is for a triangle, and obviously you can't have a right triangle with a negative side length, so that would make no sense. But in different scenarios, don't be surprised if sometime in the future you end up with like a plus or minus right there. It's not that big of a deal. All right. This one I put in a radical. So again, squaring is the inverse of a square root. So now at some point we're going to need to square both sides. We can do that now or later. I see that we are multiplying this. I'm trying to break this L free. So I'm going to have to get rid of this 2 and the pi. So I'm going to start off by dividing. And then it's always good to rewrite to keep your work kind of neat. So 2 pi equals, now I've got the radical piece alone and isolated. So my next step would probably be, let's get rid of that radical by squaring both sides. Don't forget to put this whole mess in parentheses because you're squaring the entire thing. That is going to break that free. So we have t squared over 4, excuse me, pi squared. And we have L over G. All right, we are almost done. We have to get rid of this divide by G. The fraction is the piece that we now have trouble with. And so if we have L over G, the best thing to do is to multiply both sides by G, because multiply undoes divide. So that's going to cancel that right there. And now you can see we have L by itself. So let's rewrite our final answer. It is G over 1. So G is in the numerator. So it's L equals GT squared over 4 pi squared. I think I have one more. Yep, here we go. And again, I gave you one. Practice it if you'd like. I threw out another fraction here for us because I know that that's something that students often struggle with. So my first step would probably be to get rid of that fraction by clearing it. Let's multiply both sides by 3. Let's get rid of it there. So I have 3v equals 4 pi r cubed. We need to get r by itself, so I'm going to divide by 4 pi. I'm going to divide by 4 pi. It's going to cancel that all out right there. So I have 3v over 4 pi equaling r to the third. So what is the inverse, or we like to think of it as being the opposite, but the proper word is actually the inverse of cubing something, and that is cube rooting that item, so let's cube root. And so that is going to break that free, and we'll just end up with r. So r equals the cube root of 3v over 4 pi. Now, I know what some of you might be thinking. Am I allowed to have a radical in the denominator of a fraction? And oddly enough, on my teacher's addition, they keep the answer in this radical form. They don't rationalize. Stay with me here while I change to another. Can I add a screen? Well, we can just go down here. All right, stay with me here. Let's pretend for a moment that we got an answer like x equals y over radical 2w. Okay? In the teacher's edition of my book, it would keep it like that, and it would not rationalize. Again, my math lab, we're both kind of experiencing this together, and so we would need to rationalize that denominator, and so we would have y radical 2w over, and then 2 times 2 you know is 4, w times w is w squared, so when that becomes underneath the radical, the whole point of doing this is so that the radical breaks free, and you end up with 2w, and the radical moves from the denominator into the numerator. You will not have to rationalize a cube. We did not cover that in chapter 10, or if I did, I just touched on it real quickly, because again, it's just virtual and it's difficult to show every example of every little thing in a virtual setting here on the first go around. So I did not cover that extensively, but you might have to rationalize just a regular old square root. So, okay, I hope that's super helpful for 11.4. You guys take care and have a great holiday. Thank you.